Hello, welcome back. Okay, so we'll continue. All right, still on Kirchoff's law, and in this video, we are looking at examples. Okay, so this example question will help us understand Kirchoff's law better. So now, this is a circuit I have here before me, and I'm to analyze the circuit. And I told you that circuit analysis is simply a process of actually determining the current and the voltage across the circuit element. So if you are asked to analyze or to solve the circuit, you are invariably asked to find the current across each of these resistors as well as their voltage. All right. So now for us to do that, we are going to apply Kirchhoff's current and voltage law. Okay. So this is a good opportunity for you to really understand how to apply Kirchhoff's law. Okay. So now I'm going to actually write out the step that will help you, okay, with Kirchhoff's law. The very first step, okay, is to apply KCL. Apply KCL. Okay. Now you apply KCL directly to the circuit, then you use the KCL, apply KCL to label the current across each of the resistor. This is very important. Okay, so we need to use KCL so that I'll be able to label directly in the circuit the current across all these resistors. So that's the very first step, step one. All right. Then the step two is apply KVL. Okay, uh, for each loop. All right, to in order to create you apply KVL for each of the loop, right, so that you'll be able to create system. To help you to create systems of equations, because in actually applying Kirchhoff's law in circuit analysis, you are going to be looking for many variables. Okay, for instance, um, if I'm being asked to find the current, the branch current, I have more than one branch. Okay, in fact, this circuit is made up of three branches: branch one, branch two, branch three. So that simply means that I will have three unknown currents. Okay, and for me to solve three unknown current, I will need system of equation, other system of equation that is made up of two equations, three equations, depending on the number of variables. So the very first step is for us to just to use the KCL to label the current across each of this resistor. Then we now apply KVL to generate our system of equation that will help us solve for the unknown. And this unknown include the current and the voltage across each circuit element. So let's start. All right. So I'm starting with the very first type, which is applying KCL. Okay. Now let's apply KCL. So how do I apply KCL? Okay. Let me start with this loop. I have two voltage source. So let's look at the situation. Current actually flows. Okay. Then there's a junction. So I'm going to apply KCL at this junction A. So now current reaches this particular junction. It branches, okay, and passes through 2 ohm resistor. It still branch again. Okay. So now remember KCL said that the algebraic sum of the current entering into a branch, entering into a junction, is equal to the algebraic sum of the current leaving the junction. All right. So let me actually let me call this current, that is the one that is actually leaving this junction, to be I1. Then the one that is okay, leaving through, that is passing through, let me call the current that is passing through the 2 ohm resistor I1. Then let's me call this one I2. Okay. So according to Kirchhoff's law, since I1 is leaving this junction A and I2 is still leaving the junction, that means the current that is actually going to be passing through, the one that is entering the junction, is going to be the sum of I1 and I2. Okay. So invariably now I can now conclude that the current that is passing through this the 2 ohm resistor, okay, is the sum of I1. Please pardon me. Okay, it's going to be equal to the sum of I1 plus I2. All right, so I've been able to label this current and this one here. Okay, now of course, this the I1 and I2, okay, we're still gonna be the current that will be passing through this resistor 2 ohm. All right, and here the I12 will be the same current that will be flowing through this resistor, okay, 2 ohm. So I have labeled the current across each of these resistors. So that is the first step. So that is the first step, is to label the current across each of the resistors. Then the second step now is to apply our KVL, right? So this is checked. So number 2 is KVL, okay, for each loop. Now I'm going to use 2 loop, in fact 2 mesh. Okay, I have mesh 1. Now for simplicity, let me call it loop. Okay, let me call it loop mesh 1, then mesh 2. Okay, so now I will actually choose a kind of a direction. Each of the loop will choose a direction of flow of current. Now by standard, current is supposed to flow from through the negative end of a battery, okay, to the positive, okay, from the negative to positive. So if I want to go by that standard, okay, if I want to go by that standard, we'll so I'm looking at this loop. Current flows in anti-clockwise direction. Then this one, okay, current flows in a clockwise direction. Okay, so this current flows in a clockwise direction. Okay, let's start with the first loop. This one, loop 1, this loop 1, and this is loop 2. Okay, so now remember KVL said that if we sum the voltage around the loop, okay, the sum of the EMF around the loop is equal to 0. Okay, and I told you that the reason why it should actually be equal to 0 is simply means that some of the voltage will be negative, right? They will have negative value. Now the question is, how do we know the voltage that we have negative value? Okay, and that is exactly what I want to show you now. So I want to show you the sign convention in KCL. Okay, how do we know when a voltage across a component is positive or negative? Now let's start with the voltage source, the supply. Okay, of course you know that this terminal is positive, have positive and negative terminal. So if we are looking at a flow from negative to positive is a rise in potential. Okay, rise in potential, and since it's a rise in potential, it will have positive side. Okay, that is but if it is in opposite direction from positive to negative, is a fall in potential, so we are going to apply negative side. Okay, then let's look at uh resistor. Now when current is flowing through a resistor, okay, let's say in this direction, the very first terminal of the resistor, it receives, okay, depending on the connection. Okay, since the current, we're looking at current from negative to positive. So invariably this, the very first, this terminal of this resistor is connected to the positive since we are moving in this direction. Okay, the second terminal is connected to negative, right? So in that convention, you now discover that the flow now across this resistor is from positive to negative, and the positive to negative is false. So that simply means that when current flows in that manner through a resistor, then definitely there's a fall in voltage. It will have negative side. Okay. All right. Now, for this to make sense, now let me clear let me clean up so that we solve this question. Okay. So I want to clean up. So I'm starting with loop one now. Remember, I need to actually solve for loop one and loop two so that I'll be able to create equations. Okay, equations. Um, okay, so here we go. So starting with loop one. Okay, which one do I start with? Okay, let me go with loop one. Now I'm going this way from negative to positive, which is a rise in potential. So that means the voltage of this cell is positive. All right, since I'm going like this from positive, from this side is negative and this side is positive. So I'm going from negative to positive. So that's going to be plus. So as I go, okay, then I'm passing through this 2 ohm resistor now. This 2 ohm resistor is directly connected to the positive. So the other end is negative. Now the flow is now from positive to negative, which is of course is minus. Okay, so that's gonna be minus. Now how do I actually uh write the voltage? Okay, how do I express the voltage of a resistor? Don't forget, from according to Ohm's law, voltage is always equal to current multiplied by resistance. Okay, and the current across this resistor 2 ohm is still the same current across this solar resistor because it's connected in series in that loop. All right, okay, the same current because it's coming, it's the same current that is flowing through the loop from the source. Okay, so that will be, okay, that is gonna be I1. Okay, so this I1 is still flowing through this 2 ohm resistor. So that's going to be I1, then multiply by the resistors. Okay, and the resistance is 2. So that's going to be 2 times I1, right? I1 times 2. So now I am still moving across the loop. Remember, I still have to pass through this 4 ohm resistor. Now, passing through this 4 ohm resistor, don't forget this side will still be positive and this side is going to be negative. From positive to negative is still going to be it's a falling voltage. So that's going to be minus. The current across the 4 ohm resistor is I2. Okay, so that's going to be I2 times 4. Then here I go, passing through in the same direction. Okay, now if I come here, this is positive since I'm going in the same direction. Okay, as I'm going in the same direction, the very first terminal will be positive and the second is negative, and that is still a fall in voltage. Okay, so and that will be minus I1 times. So according to Ohm's law, the sum of this voltage drops, okay, is equal to 0. So let me write it. Let me multiply that. 2 times I1 will be 2I1, 4I2, then 2I1 is equal to 0. Now let's collect like terms together. Okay, collecting like terms together. minus 2i1 minus 2i1, that will give me 4i1. Okay, so now what I'm going to do, I want to express it in form of equation. So I will take the variables to the other side of the equation. So here I have 2 is equal to minus 4i1. If I take it to the other side, that will be plus 4i1. Then I'm left with minus 4i2. If I take it to the other side, that will be uh, plus 4i2. So I call this equation 1. So loop 1 now have yielded equation 1 for me. All right, so this is KVL for loop 1. So now let's look at the KVL for loop 2. Okay, KVL for loop 2, we will move up from negative to positive, which of course should give me a positive. Okay, should give me a positive voltage. Okay, here we go. So that's going to be plus. Plus 4. Okay, so I go to, don't forget that the current is actually branches. This is the direction of the current through this. Okay, so okay, so if I still go through, this is gonna be, this is connected to positive and this is connected to negative. All right, so that's gonna be from positive to negative, a drop in potential. That's gonna be minus 2 times the current. The current through the 2 ohm resistor is I1 plus I2. So I put that in a bracket. 2 times I1 plus I2. Okay. So I still move. Then I enter into this branch. Okay. So by entering into this branch, I'm having negative to positive. Okay. This time around, negative to positive. And that's going to be a rise in potential. So that's going to be plus. So that's plus 4i2. Okay. So here I go. Cross this branch. This is positive. This is negative. Okay. I hope you know that. Oh, please pardon me. This is negative and this is positive. Connected to negative. Okay. So the other one is going to be positive. So as I go like this, this is going from positive to negative. That's a fall in potential. Okay. So that fall in potential, that's going to be I minus, of course, the current through these 2 ohm is still going to be the current across this other 2 ohm because it is connected in series. Okay. In with the other resistor in loop 2. Okay, so that's still gonna be, so this current I1 plus I2 will still be flowing through this 2 ohm resistor. So here we go, minus 2 into I1 plus I2. Okay, so everything is equal to 0, don't forget. So let's open the bracket. This 4 minus 2 I1 minus 2i2 plus 4i2 minus 2i1 minus 2i1 again, 2i2, please pardon me, is equal to 0. So collecting like terms together, minus 2i1 minus 2i1. Okay, that's 4i1 minus 2i2 plus 2i2, that's plus 2i2. Okay, then 2i2 minus 2i2, that actually gives 0. So from all indication now, I have that 4i1 is equal to 4. Then I can I1 directly now is equal to 4 over 4, which is 2 ampere. Okay, so now having gotten my I1 now, don't forget that this was supposed to be my equation 2, but it has given me my I1 directly. So with that now I can get my I2. Okay, so by substituting, so I will have that 2 equal to 4. 4 times I1, 4 times 2, okay, plus 4i2. So this is 6, right? So I have 4i2 now will be equal to 6 minus 2, or 2 minus 6, please pardon me. 2, take this to this other side, does 2 minus 6. So 4i2 is going to be equal to minus 4. So I2 now is going to be minus 4 all over 4, which is minus 1 ampere. Okay, so I'm able to get the branch current. Okay, so I1 and I2. Okay, so now let's analyze. Remember, the whole idea is for us to get all the current across this resistor. So I've already gotten the current across this 2 ohm resistor, which is I1, and that is from what you calculated, I1 is 2 ampere. Okay, then I2 is minus 1 ampere. So I've gotten the current across this. Then the current across this 4 ohm resistor, I've gotten it. Okay, so now I need to get the current across this 2 ohm resistor. Don't forget that this 2 ohm resistor is the sum of I1 plus I2. Okay, so um so let's get that. I1 plus I2 is equal to 2 minus 1, which is 1 ampere. 2 minus 1 is 1 ampere. Okay, so and that is it. So the next is just for us to get the individual voltage. Okay, let's start with the voltage across the 2 ohm resistor. Let me call it V1. Okay, so if we are looking for V1, the two, okay, or let me call it VR2, voltage across 2 ohm resistor. Now voltage is current times resistance. The current across 2 ohm resistor is I1, and the I1 is 2. Then multiplied by the resistance 2. So that gives us 4 volts. Okay, let's look at the um okay the voltage across the 4 ohm resistor, and of course with what now the current across that is across this 4 ohm resistor is I2, and our I2 is minus 1. Okay, so that's going to be minus 1 times 4, which is minus 4 volts. Okay, so that is just basically how you apply Kirchoff's law. Okay, So it can equally get the voltage of the other circuit element. Okay, so we're still gonna look at more example, right? And that will be the next video. So see you in the next video. Thank you very much.